What about a reduction formula for the integral of cos to the n of x dx? That's cos nx dx. So we are going to deduce a reduction formula for this integral and apply it to solve problems. All right. So watch to the end and see how it is done. A reduction formula for the integral of cos n x dx. The integral of cos n x dx can be written like this. The integral of cos n minus 1 x cos x dx. How? I actually split this cos nx into 2. This cos here has the power of 1. This one has the power of n minus 1. So if I add n minus 1 and 1, I will get n. Because n minus 1 plus 1 is equal to n. They have the same base, right? So we can add their powers to get this. Using the technique of integration by part, the integral of u dv is equal to uv minus the integral of v du. We choose cos to the n minus 1 x as u. I'll say let cos n minus 1 x be equal to u. Okay, or seeing u equal to cos n minus 1 x. Then we differentiate u with respect to x. This cos to the n minus 1 x can be written like this. Cos x raised to the power of n minus 1. Okay. So, differentiating u with respect to x will be equal to this. To differentiate this, we are going to make use of the chain rule. Alright. I'll be using a shortcut to differentiate this. Just watch. For the chain rule, this is the shortcut. The power is n minus 1. Write it down. The function itself, cos s, okay, differentiate it. If you differentiate the cosine function, you are going to obtain the negative sign. Write it down. Now, write the function itself, which is the cos of x, then subtract 1 from the power as n minus 1 minus 1. This is a shortcut. Instead of doing dy ds equal to dy du times du dx, that's a long process. So write down the power multiplied by the derivative of the inner function multiplied by the function itself raised to the power of n minus 1 minus 1. You get it? So we'll be having minus into n minus 1 sine x and cos x to the power of what? N minus 2. Okay, which is the same thing as saying minus into n minus 1 sine x cos n minus 2x. You get it? Good. So we have chosen u as cos n minus 1x, right? Then the other one will be chosen as the v, which is this cos x ds. So dv is cos x dx. And to get v, we integrate both sides. The integral of the v is v, and the integral of the cosine function is the sine function, right? So applying that formula, we have the integral of cos nx dx was u. Cos n minus 1x is u. Was v. This is v sine x. Minus the integral of v sine x, du, was du. Du dx is equal to this. So if we cross multiply, we are trying to say that du is equal to everything here, which is everything here, times dx. That will be minus n minus 1 sine x cos n minus 2x dx. This is du. We got it from here. From here, this equal to this. So if we cross multiply, du will be equal to everything that we have here. So I'm going to write this now in place of du. So I'll be writing sine x into minus, okay, watch, there's a minus here, so to give us a plus, I'll just write n minus 1 sine x cos to the n minus 2x dx. Yes, okay, this is cos to the n minus 1 x sine x plus n minus 1 is a constant because we're integrating with respect to x, so it will come out into the integral of sine x is sine squared x. So let's write cos n minus 2 s sine squared x dx. Now, look at the original function that we have, the original integrand cos nx. What we have here is in terms of cosine and sine. So we want to reduce that integrand to contain only cosine rather, because what we have at the beginning is just in terms of only cosine. So let's look for a way to reduce this integral to contain cosine terms only. So we have cos to the n minus 1 x sine x plus n minus 1 in brackets into the integral of, remember in trigonometry, sine squared x is equal to 1 minus cos squared x. So in place of sine squared x, I'll be writing 1 minus cos squared x. So this is equal to cos the n minus 1 of x sine x plus n minus 1 right into the integral of this times this, we still have cos to the n minus 2x, and this times this we now have, I'm splitting the integral now. If I add, since they have the same base, I will add their powers. N minus 2 plus 2, that is n minus 2 plus 2, which is n. So we're having cos nx dx. There should be a dx here. Okay. Now, oh, this should be in brackets since that n minus 1 is multiplying this integral. If you check very well, what we have here is exactly what we have here. That's what we have here. They are the same. Okay, see, let's call this integral I sub n. Let's call this okay, let me write it down. Let me bring it down. Let the integral of cos nx dx be equal to I sub n. If this is so, it means that what we have here will be I sub n. These two integrals, they are similar, but they are not exactly the same. You get it? Here we have n, here we have n minus 2. So it's like saying this one is a function of n, and this is like a function of n minus 2, right? So if this one is I sub n, then this one will be what? I sub n minus 2. So therefore, this right hand side will now be cos n minus 1 x sine x plus n minus 1 in brackets I sub n minus 2, which is for this, minus this one is what? I sub n. Here we have I sub n. This integral here is what we have here, and this is equal to what? I sub n. So actually I sub n is equal to everything we have here. Now we are going to make I sub n the subject of the formula. We have I sub n here. We also have it at the left hand side. So if I expand that right hand side to be so collecting like terms, we have I sub n plus n minus 1 I sub n to the cosine of n minus 1 x sine x plus what? N minus 1 into I sub n minus 2. So here we have I sub n common to these two. Break it out, we have 1 plus 1 left here plus what was left here, n minus 1, equal to the cosine of n minus 1 of x sine x plus n minus 1 into I sub n minus 2. So finally, we divide both sides by the coefficient of I sub n. 1 minus 1 is 0, so that one is out. We now have I sub n is equal to, divide everything there by n, cos to the n minus 1 of x sine x, divided by n, we have 1 over n. Divide the other part by n also, we have n minus 1 over n into I sub n minus 2. And this is the reduction formula for this particular integral, right? Let us now use this reduction formula for the integral of cos nx ds to determine the integral of the sixth power of cos x with respect to x. So I sub n is equal to 1 over n cos n minus 1 x sine x plus n minus 1 over n into I sub n minus 2. Now, n here is equal to 6. That means we are trying to evaluate I6, right? So going by the reduction formula, it will be this. From here we have 1 over 6 into cos 6 minus 1 is 5 plus that will be 5 minus 6 minus 1, which is 5 over 6. I sub 6 minus 2 is 4. So what is I4? I4 will be equal to, using the same formula we have, 1 over 4 into cos 4 minus 1 is 3. That will be 3 over 4. I4 minus 2 is 2. I2 is 1 over 2, right? Into cos 2 minus 1 is 1. 2 minus 1 is 1, so that will be 1 over 2 I naught. Alright? I hope you know that I4 is the integral of cos 4x dx. I should have written that earlier. And I2 is cos squared x dx. So I naught is the integral of cos x to the power of 0, right? Anything to the power of 0 is 1. So this is the same as saying the integral of dx. Integrate dx to get x. So I6 therefore is equal to 1 over 6 cos 5x sine x plus 5 over 6. I4, for I4 I'll be writing this. Okay, we expand, we have 1 over 6 into the cosine to the fifth power of x sine x plus 5 over 6. Okay, it will be 5 over 24 cos cube x sine x. Alright, 5 times 3 is 15. 6 times 4 is 24. Into I2. What is I2? This is I2 here. That's 1/2 into cos x sine x plus 1 over 2 I naught, right? I naught is just x, so I'll just write my 1 over 2 of x. Then I'll add a constant of integration to it, since I am done plugging in all the subscript of I. So I6 is this. 1 over 6 cos 5x sine x plus 5 over 24 cos cube x sine x plus, we now multiply that bracket. That will be 15 over 48 cos x sine x plus 15 over 48x plus c. 3 can divide 48 and can divide 15. 3 here is 16, 3 here is 5, 3 here is 16, 3 here is 5. So we have a simplified version of these results. 1 over 6 . Now that you are done watching, don't forget to subscribe, like the video, and share it with your friends and your classmates. I hope you enjoyed it.